Good morning to all. Well, myself Dr. Rajeshwari HV, working as an assistant professor in chemistry, JSS College, Gokak. In this video, I am going to discuss the instrumentation behind mass spectroscopy. In the previous video, I had explained the basics and theory behind mass spectroscopy. According to this, the working principle behind the mass spectroscopy is the molecules are converted into ions by bombarding with the high energized electrons and separated based on the mass to charge ratio, that is m by z and m by e value. So, on bombarding the analyte with the high energized molecules, this results in the formation of the molecular ion. The molecular ion, being unstable, undergoes fragmentation, resulting in the formation of fragment ions. The fragment ions as well as the molecular ion is separated based on the mass to charge ratio and displayed in the mass spectrograph. So, which is the plot of the intensity or the natural abundance along the y-axis and m by e ratio along the x-axis. Mass spectrometer performs four main functions. The first one is production of ions in the gaseous state, and second one is acceleration of ions in the magnetic and electric field, and third one is separation of ions in mass analyzer, and the fourth one is detection of ions based on m by e or m by z ratio. Well, these are the components of mass spectrometer. There are five important components. The first one is the inlet sample inlet. Then the second one is ion source, where the production of ions occurs here, and third one is mass analyzer. The separation of ions occurs in mass analyzer. Then the fourth one is a detector. The ions are detected here, and the last one is data system, which includes signal processor and the recorder. And the mass inside the mass spectrometer, the pressure of 10 raised to minus 5 to 10 raised to minus 8 torr is maintained using the vacuum system. In the first unit, that is the sample inlet, the sample may be taken in the form of gaseous, liquid or the solid form. If the sample is in the gaseous form, there is no problem, but if the sample is in the liquid and the solid form, then we cannot bombard the liquid and solid sample with a beam of energized electrons. Therefore, so we have to convert liquid and solid to the vapor phase or the gaseous phase. For this purpose, the vaporization chamber is provided with a heating coil. So, when we increase the temperature of the heating coil, the solid or the liquid sample vaporizes. So, by which we can bombard with the energized electrons. That is, if the liquid and solid samples are converted to vapor, then we can easily bombard the vapor phase with the high energized electrons. And the second point is, so mass spectrometer is provided with a vacuum pump, and inside the mass spectrometer 1 microtorr pressure is maintained. So that is a very negligible amount of pressure. So why we are maintaining a very less pressure, that is 1 microtorr? Because it facilitates the production of the ions and it also avoids the collision of the ions. So if the pressure is more, ions will collide with each other. It results in the further fragmentation. So it becomes complicated to evaluate the structure of the compound. So to minimize this error, the pressure inside the mass spectrometer is maintained 1 microtorr. Now, if 760 torr means 760 mm of mercury in the mercury column, if 1 torr means 1 mm of mercury in the mercury column, and 1 microtorr means it is a negligible amount of pressure. So, this negligible amount of pressure is maintained in the mass spectrometer. The second component of mass spectrometer is ion source, that we generate the ions. So, we have 4 different methods to generate the ions. Out of these 4 different methods, the first method, that is electro impact ionization, is the common type of ionization used. Now let us understand how the ions are produced in electro impact ionization. So this is the schematic sketch of the electron producer. So inside the chamber, so there is a tungsten filament, and when we heat this tungsten filament, it produces the electrons, high energy electrons, and on the other end of the chamber, the positively charged electrode is fixed. Since electron is negatively charged, it will get attracted towards the positively charged electrode, and the movement of electron will become increases, that is velocity of electron increases, the electrons will be accelerated. Now this accelerated electron possesses 70 electron volt. The energy of this accelerated electron will be 70 electron volt. So this energy is required to break the bond. So if you calculate the bond energy of CH, so it will be around 70 electron volt energy. So if the electron possesses 70 electron volt, so then the beam of electrons can break the bond, and this results in the formation of the ions. If the energy of electron is not equivalent to 70 electron volt, so beam of electrons cannot break the bond, and this will not leads to the formation of the ions. So the requirement here is the electron should possess the energy of 70 electron volt. And this is the sample inlet. So where we insert the sample which is in the vapor phase. When it comes in contact with the beam of high energized electrons which possesses energy of 70 electron volt, the ionization of the molecule occurs, and that results in the formation of the molecular ions, and the molecular ion, otherwise also known as cation, being unstable, undergoes fragmentation to give the fragment ions. This is the schematic sketch of the mass spectrometer. So let us understand in detail how the mass spectrometer is going to work. So here the first unit is the vaporizing chamber. The sample is inserted through the sample inlet. The sample is inserted inside the vaporizing chamber through the sample inlet. So the sample, if it is in the gaseous form, there is no problem. If it is in the solid or the liquid form, so we have to bring it to the vapor phase. For that purpose, the vaporizing chamber is provided with a heating coil. So when we increase the temperature of the heating coil, the solid or the liquid sample is converted into vapor phase, and these vapors will enter into the next chamber, that is ionization chamber, where the ions are produced here. So ionization chamber lies between the slit A and B. So as I explained previously, so this chamber is provided with a tungsten filament. So when we heat this tungsten filament, the electrons are generated, the energy of 70 electron volt, and the other side of the chamber is provided with a ion collector. So when the vapors, that is analyte, come in contact with high energy energized electrons, so there is emission of one electron from the analyte along with the bombarded electron. So there is formation of molecular ion with the emission of 2 electrons, and molecular ion being unstable undergoes fragmentation, leads to the daughter ions, that is M1 cation and M2 cation. Now in the chamber we have 3 ions, that is molecular ion and 2 daughter ions. The molecular ion and 2 daughter ions will move into the next chamber, that is ion acceleration chamber. So this lies between the slit B and C. Ion acceleration chamber. So as the name indicates, so we have to accelerate the speed of the ions here. This chamber is provided with the electrodes, so which has the potential of 8 to 10 kilowatt. The first electrode is positive potential is applied, and ion is positive, so it will attract the electrode, repel the electrode, positive electrode, and the second electrode is negative potential is applied, and the ions will get attracted towards it, and the third one is made more negative potential, so ions are attracted towards the third electrode. So by this way, by increasing the potential from positive to negative, the speed of the ions is increased. So the ions, that is the 3 ions, molecular ion and the 2 daughter ions, will move into the mass analyzer. The mass analyzer basically has the circular path and it has the magnetic field inside that. So now these 3 ions, so we have the biggest molecular ion, the medium sized daughter ion and the very small daughter ion. So out of these 3 ions, which will move faster and which is first detected in the detector. Now to answer this question, we have to understand what is second law of Newton's second law of motion. In the mass analyzer, the kinetic energy of the ions, that is molecular ion and the 2 daughter ions, is expressed as, that is half mv square is equal to E capital V, where small m stands for mass of the ion and small v stands for velocity of the ion and E is the charge and capital V is the potential applied. So where the ions, these 3 ions, that is molecular ion and 2 daughter ions, enter into the magnetic field which is provided in the mass analyzer, these ions will be deflected. So they will change their actual path. So based on if the heavier ions with a more positive charge, that is +2, are deflected the least. If the ion is light and less charge, +1, they are deflected the most. The deflection of the ions can be visualized here. So this is the mass analyzer, enlarged mass analyzer. So we have the 3 ions, the bigger molecular ion, medium sized cation and very small sized cation. Now you can see the path here. The path of the heavier ion is least deflected, so that's why it will reach first, whereas the path of the medium sized cation is deflected slightly, so it will reach second, and then the path of the lighter ion is deflected the most, so it will reach at last. Hence from Newton's second law of motion, that is HEV is equal to mv square divided by r, that is equation 2, where H is applied magnetic field and r is radius of the path. Then squaring both sides of the equation 2, we have H square E square V square is equal to m square V to the power of 2 divided by r square. Now V square and V square will get cancels with each other. Then we have H square E square is equal to m square V square divided by r square. This is equation number 3. Since from equation 1 we have half mv square is equal to EV, then we can write mv square is equal to 2EV. Then substitute the value of mv square in equation number 3. So in place of m square V square, then we can have H square E square is equal to m into 2EV divided by r square. E and E will cancels with each other. So we can write the expression as H square E is equal to 2mv divided by r square. That is equation number 4. Equation 4 is rearranged to m by E is equal to H square r square divided by 2v. This will give equation number 5. Now this equation will explain which ion is going to move faster in the circular path of the mass analyzer. So according to the explanation made earlier, the biggest ion will move first, so then it is followed by the medium sized ion, then at last the smallest ion will move. So the first detected is the biggest ion, then the second one is medium, and then the last one is the smaller ion. And the ions are detected using the detector micro channel, and it is collected, ions are collected and it is amplified and recorded. Now we can see here, so we have 3 ions here, the biggest, medium sized and the smaller ion. The biggest ion will reach the detector first, then followed by the medium sized ion, and then we have the smaller ion. So it is detected by the detector, then it is amplified and recorded. The mass spectrum is obtained, that is the natural abundance along the y-axis and m by E ratio along the x-axis, and these ions are separated based on their m by E values. So this is how the mass spectrum is going to work. Thank you.